Hello, everyone, and welcome to another Tech Tuesday by BitCube. So today we are going to be doing some of the final additions to our Flappy Birds game. So this is just going to be some very small changes, like basically adding our scoring system, and then also just adding some minor difficulty settings. Now, the difficulty settings won't really be needed for our next video, which is going to be the actual machine learning, although I'm still um, deciding what method I want to use. I thought the easiest way would just be to use neural networks, which basically just accepts two inputs, um, which is going to be the let me just get this started and just let me crash it. And those inputs will basically just be the distance the bird is currently from its next pipe, and also the distance between the pipes, and then it'll just take that and come up with an output, which is going to be how the bird should fly, if it should stall, go down, or if it should fly up. So it's really going to be a actual uh, simple implementation to get that working. But yeah, that's going to be for the next video, which is going to be the final one. But anyways, in this video, we're just going to be adding the scoring system. So just to rack up the points and give incentive to the bird. So if we use something like reinforcement learning, that'll give some incentive. The higher the bird scores, the better it will do. Um, so yeah, we'll add that. And then we're also just going to change something from the last video, which is these bottom pipes. So if you watched the last video, you know that these bottom pipes are all still static, only the top ones change in height. So we're just going to add that same thing for the bottom pipes, just to make it, a little bit more nice looking. Also a bit more difficult. So if you have a gap here, you'd also like to have a gap at the bottom, so that you can actually have some better maneuvering through all of these obstacles. Um, but yeah, I think that's about all we're going to do, and also just add the helper methods to get the distance from the bird between the pipe. And that's going to be it for this video. And this time we're going to be doing it from scratch, not like the refactoring one where we just cleaned up the code. So yeah, let's get started. So for the scoring system, the first thing we would need is a basically a data store, just to house our scores. And once we add the difficulty, if we actually get to adding the difficulty, depending on the time, um, if we don't get to that here, we'll add it in the next video. But yeah, so first thing, I think if we want a data store, is basically we can just create a singleton. So let me just create a new file here and call it, let's just call it game data. There we go. Cool. So now we have a file called game data. So I'm not going to go into detail about how to create singletons. I'm just going to create one here. But all you need to know about this is it's just a basic data structure that keeps uh, its class alive throughout everywhere you want to use it throughout this project once it starts. So if I call this class and I create it here in the setup function, I will be able to use it in the draw function. I will be able to use it in the background file, the bird file, or the pipe file, while it still maintains its exact same data. So that's very useful if you want persistent data throughout anything, your app, your game, whatever you want. So first thing I'm going to do is I'm just going to create a public static class, and we will just call that game data. There we go. And then inside of this class, I just want to have a private variable, private static variable of game data, and we will just call this the instance. There we go. See, just because it's not used. Cool. And then to finalize this, we just want to create a private constructor. So private constructor, game data, there we go. This will just be used to initialize any default variables we will have in this game store. So basically, in our case, if we want um, to house the score, you can just have that here, and then set the score to 0 once the class gets initialized. And then finally, what we would want is just a public class to get this instance. So that'll just be public. It will return a instance of game data, and then we'll just call this get instance. There we go. And just remember that this has to be static. Cool. Okay, so we have that. And inside of here, we would just want to, well, return the instance. But at this point, the instance doesn't really exist. So we will first want to check if the instance is null. We would just like to give this instance a version of this class. That's basically it. Singletons are not really, that hard to create. So here we currently have one. We can add some helper methods like to increase the score and fetch the score, stuff like that. But I really don't think that's necessary right now. So currently we'll just keep it like this. All right. So now that we have something that can house our score and actually utilize it, we can start implementing it. So first of all, in our actual game file, we would like to just let's draw our score currently. Here we go. Draw current game score. There we go. And to do this now, all we need to do is we need to, I'm just going to use some processing framework helper methods to draw the score. So first thing would be to just declare a text size. This will just be the size of all text that I will write to the canvas. And then after that, we will just write our text to the canvas. You can use this by just using the text function, also built into the processing framework. And from here on now, we would just want to call this class that we created, game data, and then we'll just use the get instance method we created and actually call that score that we have. So this will just give us the score, and anytime we update this score wherever throughout our files, it will register here as being updated and then just build up from there. So now the next two arguments, we just want to declare some sizes. So I think the 5, basically just 5 pixels from the left side of the screen. Just give it some spacing to make it look nice. And for the Y, we're going to have to play around with that because it kind of writes it from the bottom left. So we just have to play around with getting the perfect size. So I think let's just use 65 and see what we get. So if I play the file again, there we go. Okay, so I can use a little bit less on the Y, but now we actually have a score there, and it's initialized as 0 because we didn't really add the increasing of the score yet. So we'll do that now. Let's just fix the size first. I think let's use 58. Just see. Yeah, yeah, no, okay, that looks good. So there we go. Oh yeah, I didn't even mention this. The reason I am adding this drawing function here um, at the bottom is just because of the order that I am rendering all of these files. So you'll see if I do actually go ahead and render this, let's say first or something, like right there, it's not going to work because it's going to be now rendered in the background. So that blue cover we have there is actually covering the score now. So just remember when using the processing framework, or actually just when rendering anything in anywhere, order does actually matter. So let me just add this back to where it was. There we go. Okay, cool. We have our score. Now we, want to actually add the functionality to update our score, and this is also really, really, really easy to do. Um, let's. There's going to be a little bit of a trick to this, but I'll get to that now. So our collision detection is inside of our pipe class. So basically, that's definitely where we're going to be adding our score calculations. So what I want to do is basically, if we look at how this works, if the bird passes right through it, let's just cancel there. The moment the bird passes through it, the actual pipe will be on the edge of the screen. So every time the pipe hits the edge of the screen, we want to increase the score. So to do that, we can just say if um, we called those um, x sizes gap diff. So if the gap diff of whichever pipe we're using, since we're looping through all the pipes, we can just say whatever pipe we're using is less than 0. We want to call our game data class. We want to get the current instance that it's working with. We want to get the score from there and update it by 1. Now you'll see there's going to be an issue here, but it's a really easily solvable one. So if I play this, now you'll see once this first pipe goes through, boom, it updates the score, but now it's going crazy. It's just updating the score constantly. That's not what we want. We want it to only update once every single time a pipe passes through, not the moment a pipe passes through, just constantly increase that score. So this is really easy to fix. So what we're going to do is just create a new variable inside of our pipe class, which will be a array of booleans, and we will just call these score triggers. So basically, once the pipe hits the end, the score trigger will go off so that it detects, okay, we have already calculated a point towards this pipe, and we do not want to, just constantly increase the score there. And once the pipe gets re-rendered at the right side of the screen, we want to detach this trigger so that it actually, once that pipe goes to the end again, it picks it up as a score again. So for that, we just want this Boolean array of score triggers. So the reason we're using a Boolean array is because we can initialize any amount of pipes. So this array will just hold the trigger towards whatever pipe we're working with. So we can just go ahead and initialize this. Score triggers equals a new Boolean array with whatever amount of pipes we're working with, and then we want to just default set these to false because they have not been triggered. So just set each and every one of these triggers back to false. And that's easy enough. So now we want to go in our calculation where we update the score, and we just want to say if the gap is less than 0 and the score has not been triggered yet. So score triggers I. So if the gap is less than 0 and it has not been triggered yet, go ahead and actually trigger the score, but also go ahead and set this trigger now to true. Since now we have triggered it, it'll go through here once, set it to true, and then this will never trigger again. So if we just keep it like this, let's just do a quick test. If we just keep it like this, we should actually, since we're only using 3 pipes that re-render, our score should be limited to 3, 3, and then we'll never, because these are reused assets, these will never update again. So to fix that, also very easy. Here is where we re-render our pipes. So this detects if, from the previous video, if the pipe has reached the end of its life cycle and gets respawned back at the end of the screen. So the easiest way we can do this is if we just take this score trigger and actually set it to false. So once it reaches the end of the screen, set it to false. Its gap difference will be way bigger than 0, so we would not have to worry about this triggering. And then its trigger will be back to false again, so only trigger the score update once it's back to the left side of the screen. So with all the work we did now, we should actually have a nice scoring system that goes past 3. So 1, 2, 3, 4, 5, and so on and so forth. And yeah, this will just keep going on and on and on forever. Here we go. And there you have it. Now we have an actual scoring system for a game. So just with this scoring system alone, we actually would be able to do some incentive training on this game to get the bird to act like a bot that plays the game itself, which is also just very simple. But that's not what we want to do in the end. We want to use just something like a machine learning algorithm or some neural networks to train this bird by itself. So yeah, but that's going to be for the next video. Yeah, here we have it. We have our scoring system. Was really easy to implement, and now we'll just want to move on to the next part, which is just getting those pipes to actually not be static at the bottom, just to have them move up and down nicely, because it's a little bit boring if they just
Okay,
keep
so just to
themselves
save a little
static
bit
at the
of
bottom
time,
like
since
that.
I see I'm already going a little bit over time with our new shorter video formats, I just implemented the game difficulty as well as the bottom pipe shifting, but I will just go through what I actually did to implement those. Um, so first off, let's just play the game and see it in action. So as you can see, the currently now nothing is static anymore. All of the pipes move freely between the screen dynamically, and with the difficulty settings, you won't really be able to see it immediately in action, since it's currently set that every time you pass through 10 pipes, it just reduces or well increases the difficulty by a little bit. And those values, I mean, you can just change those to whatever you see fit. And currently we have a threshold of like 75 pixels, so it'll never go below that. But again, that you can change however you want. That it just depends on how you want the game to run. So first of all, let's go into how we made these bottom pipes not static. So the first thing I did, I just had to change a little bit of the calculations, like I described in the previous video, in order for us to make those bottom pipes dynamic, we just need to switch up the formula a little bit. So first thing I did is I just introduced a variable called gap for our pipes. So this is just in the loop, so each pipe has its own specified gap, and that is between 75 and 150 pixels. Again, this can be changed to however you see fit. So yeah, and then for the calculations of the pipe pointing downwards, I just made it so that you'll see I did a -1 times the screen, which just means that that pipe starts at the top most point of the screen, and then I just introduced it to a random value, which is also something you can just play around with. So in this case, I just have a threshold of the screen size times 0.2, so it'll never go past, let's say if this white canvas was the actual screen, so 0.2, it'll always be uh, at this point here, and never go lower. So this is just so that it doesn't go out of bounds of the screen. And for the bottom part, it's 0.7. So this means it'll be somewhere around like here, just so that it doesn't go too low out of the screen. And yeah, that's basically all I did for the pipe bottoms. And the pipes pointing up, that's also very easy. All I did was I made the pipes pointing upward start at the bottom of the screen, so that would be here, and I just added um, the, the the height of the bottom pipe. So if I just remove this gap part, um, and actually run it, you'll see that the pipes will always just be touching against each other. So that's all this calculation does. It just moves the pipe from the bottom of the screen up until wherever that bottom pipe we add um, is facing. So after that, I just added the random value, that gap that we added, and that was it. So now currently it randomly uh, just calculates that gap, and as well as the bottom pipe and the top pipe according to the bottom pipe. So it's just fully dynamic, and you don't have to ever worry about anything being static from there on. So in order to, so this is just in the setup function. So in order to complete that, obviously, per frame that it renders, you just have to implement this exact same formula. So that's what I did. Every time the pipes get re-rendered, which is in this statement, um, I just redid that exact formula. The gap between 75 and 150. We'll get into the difficulty now. That's very simple. And then I just redid the formulas for the bottom pipes as well as the pipes going up. So yeah, that's literally all I did for the actual moving of the pipes now. So for the game difficulty, again, just very easy. I just did something. I had the idea of just using a multiplier basically for the game difficulty. So you'll see in our data store now, I just added a difficulty setting. In this case, it's 1. So when it's 1, it's just the standard difficulty. When it's multiplied with any of our values to change them, they'll all just be the same. Uh, in which case, it'll just be the standard game difficulty. And then, in order to change that, I just had an if statement here. So every time the score mod by 10 is 0, that means you passed through 10 pipes. We just increase the difficulty a little bit. So in this case, make that multiplier go um, 0.1 value less. So every time it goes less, the gap, or the maximum threshold of the gap, will then lower with this formula. So by default, it's 150 pixels, but then every time the difficulty gets lowered, it can get less, 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 less. Obviously, when this goes lower than the minimum threshold, only the minimum threshold will apply. So it can't ever get lower than 75. but again, that you can just change, however you want. Um, but yeah, that's basically the idea I had for the game difficulty. And then this is also all we need now to finally get started with creating the actual bot that plays the game itself. So yeah, hopefully you guys found something of use in this video again. I know it was a bit short and the end a bit rushed, but yeah, this is now finally just the base setting of the game complete. We have now an actual working Flappy Bird game with difficulty increasing as well as a score count, and that is all we need to start applying our machine learning or neural networks to this game in order for it to learn to play itself. So yeah, hopefully you guys will be excited for the next video where we actually implement this learning strategy so that the game can play itself. And I think it's gonna be quite fun. So yeah, thank you guys for watching. And also you can find all of this code on GitHub, which will just be linked in the description. So if you want to check it out, play around with the code a little bit, get to know the processing framework, you can just go ahead and check out that code and play around a bit. But yeah, thank you guys for watching, and have a nice evening.